Hi student, here I am discussing about substituted cyclohexane. First one is mono-substituted cyclohexane. In a mono-substituted cyclohexane, there can be exist two different chair conformers. One with the substituent equatorial and other with substituent axial. Among these, which one is more stable? In almost all cases, the conformer with substituent axial is higher in energy. That means axially substituted cyclohexanes are less stable and exist in less amount. What is the reason for that? Let's check it. Here you can see that the substituent is methyl group at first carbon. And this methyl group have a steric repulsion from the. Here I am discussing about substituted cyclohexane from the same side. From this one is and this one. Mono means these two axial hydrogens makes a steric repulsion. In a mono substituted cyclohexane, methyl group can be substituted. Exists two different chair conformers. The steric repulsion between the substituent axial hydrogen with the axial substituent is other with 1,3-diaxial interaction. Among these, axial substituent have more steric hindrance than equatorial. More stable. In almost all cases, in the case of mono-substituted cyclohexane, substituent preferred is higher in energy. Equatorial. That means axial. Axially substituted cyclohexane. Second reason is 1,3-diaxial interactions are and equal to gauge interaction amount. We have seen what is the reason for that? Butane. Butane and the neighboring CH3 groups are came at an angle, dihedral angle 60 degree. There will be a gauge interaction, that means steric repulsion between these groups. Such gauge interactions exist in mono-substituted cyclohexane when substituent is at axial positions. This can be seen when we draw the Newman projection method of the mono-substituted cyclohexane. Here, in this figure, this is the Newman projection analysis of the mono-substituted cyclohexane. Here, if the methyl group at the axial, there will be a gauge interaction is exist. Whereas when the substituent is at the equatorial position, this methyl group is far away from the axial hydrogen atoms. So that means this is anti-interactions is equivalent to anti-interactions. In effect, the equatorial position is the preferred position for the monosubstituents. Due to the 1,3-diaxial interactions, the axial substituent have more steric hindrance than equatorial. Okay. This is the methyl substituted cyclohexane. In methyl substituted cyclohexane, this is the axial substituted cyclohexane and this is the equatorial substituted cyclohexanes. The two conformers are exist in equilibrium. These are the ring flipping conformers of first one and the second one. These two conformers are exist in equilibrium, whereas that means chair interconversion occurred, but 95% of the molecule have their methyl group at their equatorial positions. Okay, if 100 molecules are there, 95 molecules are with the methyl group at equatorial. Only 5% of molecules are occupied at methyl at the axial positions. Instead of a methyl group, if a substituent is a bulky group, that means a tertiary butyl group, steric hindrance is more pronounced with a bulky substituents such as tertiary butyl group. So, steric hindrance of 1,3-dioxyl interaction in the case of tertiary butyl substituent is higher than compared to methyl substituents. So, percentage of the existence of the acyl form is less than that of methyl substituent. Here only 0.01% of acyl substituted tertiary butyl cyclohexane exists, whereas equatorial form exists in 99.99%. That means the changing the substituent also changing the substituent also 1,3-dioxyl interaction also changed. From this table you can understand that the substituent may be chlorine, hydroxyl group, methyl, ethyl, isopropyl, tertiary butyl, like that, and corresponding 1,3-dioxyl interaction is given in the second column. Okay, the third column, the percentage of existence of the equatorial and axial ratio is given in third column. So let's compare this one. In the case of chlorine, only 2 kilojoule per mole of 1,3-dioxyl interaction is there compared to equatorial. So 75% of the molecules are existing equatorial form, only 30% are existing axial forms. But in the case of hydroxyl group, compared to chlorine, hydroxyl group size is somewhat greater than that of chlorine. So the 1,3-dioxyl interaction of hydroxyl group is greater 1.2 kilojoule per mole than chlorine. Hence, the equatorial form is 83% and axial form is 17% only. Methyl group, we have already seen that the interaction is 7.6 kilojoule per mole. So equatorial form exists in 95%, whereas axial form exists in 5% only. Okay, as the ring size increases, the 1,3-dioxyl interaction also increases. Correspondingly, the equatorial form, percentage of equatorial form is increasing. So, the net effect is that axial substituents are golf with the carbon in the ring. Equatorial substituents are anti with the carbon in the ring. Axial substituents have 1,3-dioxyl interactions, and axial substituents are higher energy than equatorial substituents. Hence, in the case of mono-substituted cyclohexane, we prefer equatorial position than the axial position. Next, 1,2 dye substitution. Dye substitution may be 1,2 dye substitution or 1,3 or 1,4. Okay, maybe 1,2, 1,3 or 1,4. In the case of dye substituted cyclohexane, there are cis and trans isomers can exist. That means stereoisomers are possible in dye substituted cyclohexane. That means depend upon the position of the group. That means if the groups are on the same side, it is a cis form. If the groups are on the opposite side, it's a trans form. So stereoisomer exists in dye substituted cyclohexane. The cis form is the groups are on the same side. If trans form is in the opposite sides. In the case of cyclohexane, if groups are on the same side means both the groups are present on the upward direction or in the downward direction. That means the substituent is attached by the upper bond at its carbon, or both the groups attached by the lower bond at its carbon are considered as a cis. In the case of trans, if one substituent is attached by the upper bond, the other substituent is attached by a lower bond at its carbon. Okay, that isomer is considered as a trans isomers. So, in the case of 1,2 disubstituted cyclohexanes, And see the cis form of the 1,2-disubstituted cyclohexane. Cis form means both the substances are on the same side. That means both the substances are attached by the upper bond. Both the substances are attached by the upper bond. How can we understand the upper bond or lower bond? We know the direction of axial hydrogens, where hydrogens are alternately upward direction and a downward direction. So wherever the carbon center is upward direction, the hydrogen at that point is axial hydrogen at that point is in upward direction. Okay. If this considered as a first carbon atom, this carbon is in the slightly upward direction. So the axial hydrogen on this carbon is in upward direction. Here the axial hydrogen is in downward direction. So here the axial hydrogen is upward direction. Here the axial hydrogen is downward direction. The axial hydrogen is upward direction. Here the axial hydrogen is downward direction. So we know the direction of axial hydrogen. So compared to the axial hydrogen direction, we can predict the direction of the equatorial hydrogen. If this point, if the axial hydrogen is in upward direction, the corresponding equatorial hydrogen on that carbon is in downward direction. Okay, like that. Here, the axial hydrogen is on the downward direction, so the corresponding equatorial hydrogen will be on upward directions. Okay. Next, if 1,2 substituted cyclohexane, in the case of 1,2 disubstituted cyclohexane, cis form means both the substituent are at both the substituent is attached by the upper bond. Okay, you consider this is the first carbon atom. Sorry, this is the first carbon atom, and this is the second carbon atom. See, which is the in the first carbon atom, which is the upper bond axial. So the one substituent the second carbon atom, which is the bond at the upward direction, axial or equatorial. Axial hydrogen is in the downward direction. So equatorial hydrogen is on the upward direction. So equatorial is the upper bond. So one substituent may be at the equatorial. Okay. Sorry. One substituent at the axial is upward. Equatorial is upward. So here the substituent both are at upward direction, but the one is axial, one is equatorial. But both the directions are the upper bond. Upper. So this is a ring flipping of the second form of the ring flipped form of the chair conformation. Here also what about the substituent position? Here the substituent is upward or downward. Here you know the direction axial position is upward. So this equatorial is considered as a downward. This is downward. And this axial is downward. So both are at a downward direction. So this also can be considered as cis form. That means in the case of 1,2 disubstituted cyclohexane, cis form is axial equatorial. If the one substituent axial, this two substituent, second substituent will be on equatorial, axial equatorial, or if equatorial axial, both are same. Okay. First position, if it is placed on axial, the second position should be occupied at equatorial. Then only can consider as a cis form of 1,2 disubstituted cyclohexane. Okay. Transform. The transform substituent one at upward direction and one at downward direction. Okay. That means in the first place, you know that axial is upper bond, and the second place, if we are considered that this is the second carbon atom, then The axial is the downward direction. So both are at a different directions or the different side. Okay, so this is a transforms. That means axial, both the subtend are at a axial. The one position axial and the second position also subtend occupy the axial. Then it is a transform. The second case, both the subtends. That means one is equatorial means it is in the upward direction. Here axial heterogen is in the downward direction, so equatorial bond can be considered as a upward direction. Subtend is occupied at equatorial means it is on the upward direction, and the substance occupied at equatorial in the here this carbon is here can be considered as a downward direction. So downward, upward, downward. So it is equivalent to trans conformation. So trans conformation may be either axial or equatorial. Cis conformation may be axial equatorial. Among these, which one is more stable? You know that axial substance always have a 1,3 diaxial interaction. So wherever substance occupy the equatorial positions will be the most stable conformer. So the trans equatorial conformer is the highly stable form. Most stable form is trans equatorial compared to trans axial or cis axial equatorial form. 1,2 disubstituted cyclohexane, most stable form is trans equatorial. Okay. Next one is 1,3 disubstituted cyclohexane. If the substituents are occupied at the first carbon atom and third carbon atom, then it can be considered as a 1,3 disubstituted cyclohexane. In the case of 1,3 disubstituted cyclohexane, cis form means both the substituent is attached by the upper bond at the first place and the third place. Then it known as a cis forms. Okay, let us see. The first place it is on the upward direction. The third place. In the third place, if it is occupied at the upward direction, it can be considered as a cis form. Third place also it is on the upward direction. So that means both are at axial. Axial is a cis form. Second case, the same. If both are at the downward direction, that means here these two are on the equatorial positions. So here cis form is both are at axial is considered as a cis form, and both are at equatorial. Both are the same. Okay, both are at equatorial may be considered as a cis form. Similar to transform of the 1,2 disubstituted cyclohexane. See, in the case of cis, in the case of 1,3 disubstituted cyclohexane, cis form is axial or equatorial. That means the one substituent is at equatorial, other substituent at equatorial. If one substituent at axial, the third one also at axial. Which one is more stable? Equatorial. Say cis form is more stable than axial. Cis form. The next transform of 1,3 disubstituted cyclohexane. In transform, the one substituent is attached by the upper bond, other attached by a lower bond. Okay. Suppose in the first phase, if one first position with the axial substituent is placed at the axial bond, then it is in a upward direction. The third carbon atom, it would be on equatorial. That means then only one is at upward direction and one is at a downward direction. So it is a transform. That means axial equatorial. The substituent would be on axial or equatorial. If one place it is on axial, the third place it will be on equatorial. Then it can be considered as a trans 1,3 disubstituted cyclohexane. Or if the third form it will be on axial, in the first form it will be on equatorial. Okay, it is considered as a both are same, axial equatorial and equatorial axial. Okay, transform may be one. In the case of 1,3-disubstituted cyclohexane, transform is if the first one substituent is at axial, the other will be on the equatorial. Okay, axial or equatorial. Which one is more stable? Axial, equatorial. In the case of transform, this in the case of transform, both are same. Like both are axial or equatorial. Both are axial, equatorial, and axial. Both are axial, equatorial. Both have same energy. Both axial, equatorial, and equatorial axial. In the case of 1,3-disubstituted cyclohexane, cis form or transform is more stable. Cis form or transform is more stable. Cis form is more stable because in cis form, equatorial, substitution is occurs at in cis form only. So cis form is more stable than transform. Transform is axial equatorial. Okay. In the case of 1,3-disubstituted cyclohexane, more stable conformation is both the substituent occur at equatorial and equatorial. That means cis form is the more stable conformation. Next is 1,4-disubstituted cyclohexane. 1,4-disubstituted cyclohexane. The case of 1,4-disubstituted cyclohexane, which is similar to the 1,2-disubstituted cyclohexane. Cis means same side. That means both the substituents at the first and fourth carbon atom are on the attached by the upper bond. Then it can be considered as cis form. And in the case, the first case, if the first substituent is occupied at a upward direction, that means axial. The fourth the substituent at the fourth carbon atom also placed at a upward direction, so it can be considered as cis. And if the first substituent at the first carbon atom occupied at a equatorial position, that means it on the downward direction. The substituent at the fourth carbon atom occupied at the axial position, that is in the downward direction. Both the case these are in the downward direction, so same side. So this form may be axial equatorial or equatorial axial, both are same. Okay, this is similar to 1,2-disubstituted cyclohexane. Next, in the case of 1,4-disubstituted cyclohexane, transforms. Transform means both are on the opposite side. That means one substituent occupied at the upper bond, other substituent occupied at the lower bond. If the substituent at the first carbon atom occupied at the upper bond, substituent at the fourth carbon atom will be occupied at the lower bond. That means axial. And if the one or fourth carbon atom is upward direction, and here the first carbon atom occupied at the downward direction. That means equatorial. Equatorial also is in transform. In the case, both the substituents are on the up. Both the substituent, one is at the upward direction. This is on the downward direction. That means equatorial. Okay, equatorial. And this is transform. So which one is more stable? Trans 1,4-disubstituted cyclohexane is, that means more stable among this. Equatorial is the most stable. Okay, compared to cis form, transform is more stable. In transform, equatorial is the most stable conformation. Equatorial conformation is the more stable conformation of 1,4-disubstituted cyclohexane. We discussed about the disubstituted cyclohexane. In the case of 1,2-disubstituted cyclohexane, this form is axial equatorial, transform is axial or equatorial. Most stable conformation is equatorial transform. In the case of but that is similar to 1,4-disubstituted cyclohexane. This form is axial equatorial, transform is axial or equatorial. The most stable conformation is equatorial. Okay. In the case of 1,3-disubstituted cyclohexane, The cis form is axial or equatorial. The reverse of the 1,2 or 1,4 form. Trans form is axial or equatorial. The most stable conformation is cis form, equatorial and equatorial. Okay. Next, the question may be question may be in this way: how to draw the cis trans isomers of cyclohexane on chair conformational structures? Okay, how to draw cis trans isomers of cyclohexane on chair conformational structure. That means, example, cis trans 1,4-dimethyl cyclohexane 1,4. We have already discussed in cis 1,4-dimethyl cyclohexane. Cis is in cis form axial equatorial, trans form equatorial. Okay, in cis form the methyl group on the axial and the fourth methyl group on the equatorial, then it is cis form. In the trans form, the first methyl group on the equatorial, first methyl group on the equatorial, the fourth methyl group also occupied at the equatorial, then it is a trans form. Okay. Second question: consider each of the following conformation structure and tell whether each is cis or trans. Okay, in the first case, the chlorine axial and chlorine equatorial. That means the chlorine substance is attached on the upward direction. Here chlorine is on the equatorial bond, it is on the upward direction. Both are on the upward direction, same side. So this is a cis form, axial equatorial. Okay. The second case, here chlorine, the substance is attached by the downward bond, downward. Okay, lower bond. Here, third carbon atom. The chlorine is on the lower bond. Both the substances are on the attached by a lower bond. So both are same. That means cis form. One substitute. That means equatorial, cis form. In this case, C, the 1,2-disubstitute cyclohexane. The first chlorine is at the equatorial, that means lower bond. The second chlorine is on the equatorial, that is upper bond. Lower and upper, that means trans form, axial and equatorial. Next, draw the most stable conformation of trans 1-methyl 1,4 secondary butyl cyclohexane. Draw the most stable conformation of trans 1-methyl 4 secondary butyl cyclohexane. Okay. In the case of substance, here substances are methyl group and a secondary butyl secondary butyl group. So trans means the 1,4 position is equatorial is the most stable trans form of 1,4-disubstituted cyclohexane. So if the first but the substance here is methyl group and secondary butyl group. So one place, if this is the first carbon atom, we place equatorial at methyl group. The fourth carbon atom at the equatorial place butyl group, secondary butyl group. Next, draw the most stable conformation of cis 1,4 for secondary butyl cyclohexane. This form of is, in the case of 1,4-disubstitute cyclohexane, this form is axial equatorial. So axial and equatorial. So in the case of here, the two groups, methyl groups and a secondary butyl group. So secondary butyl group is a bulky group compared to methyl group. So whenever a bulky group is came, then we will give preferred position equatorial to the bulky group. In the case of cis form, in the 1,4-disubstitute cyclohexane, axial equatorial is the position. So axial form, we will can give methyl group on the axial and a secondary butyl group, bulky group on the equatorial position. And it will be on the most stable conformation. Next, draw the trans 1,2-dimethyl cyclohexane in its most stable chair conformation. Are the methyl groups axial or equatorial? So trans. So 1, this is a cyclohexane chair form. 1, 2. Trans means in the case of 1, 2 disubstituted cyclohexane, trans means equatorial. Both the substance, a substance is methyl group placed on the equatorial position, then it will be a trans form. So are the methyl groups axial or equatorial? Both are at the equatorial. Draw cis 1,2-dimethyl cyclohexane in its most stable chair conformation. Are the methyl groups axial or equatorial? Cis. The case of 1,2-disubstituted cyclohexane cis form is axial equatorial. So one methyl groups on the axial and other methyl groups on the equatorial. Then it will be a cis conformation. Are the methyl groups axial or equatorial? One methyl group at axial and other methyl group at equatorial. Which is more stable, cis 1,2-dimethyl cyclohexane or trans 1,2-dimethyl cyclohexane? In the case of 1,2-disubstituted cyclohexane, trans form is more stable than cis form because in trans form both the substances are placed on the equatorial. So equatorial. So trans form is more stable. So in equatorial position there is no 1,3 diaxial interaction. So it's more stable conformation. Okay. These are all about the substituted cyclohexane. Here we discussed only monosubstituted cyclohexane and disubstituted cyclohexane. Okay, thank you.